In this unit, I'm going to show you how to create floor elements in Revit architecture. Just before we make a start, I just want to mention again about system families and component families, because floor elements are a good example of system families. What that means is that the elements that we create using the floor tool, i.e. the floor slabs, only exist within this particular project, i.e. the project that we create them in. We can't save those floors as a standalone component to load into other projects. So they're a good example of a system family. That is, they are created by the system, i.e. by Revit, as we need them and as we use the tool. In order to demonstrate the process of creating floor elements, I'm going to use this very simple project here. So I've got 4 walls, looking at it in plan view at the moment. I'll just switch to a 3D view. So very simple building, and if I just rotate that a little bit, you'll see that there are no floors in our model at present. I'm just going to switch to a south elevation to show you that I have 2 levels, level 0 and level 1. So I'm going to create 2 floor plates to make sure that we fully demonstrate how that process works. So to begin with, I'm going to create a floor element at level 0, and then I'll repeat the process and create another one at level 1. So I'll switch back to the level 0 floor plan. So we go up to Architecture, Floor. There's a little drop down there next to the Floor tool. Just make sure you're selecting Floor Architectural. That's the tool we want. Now at this point I'm going to mention sketch mode in Revit. You'll see this time and again for many different tools. This is the first time we've really encountered it in this course. You will see it again later when we look at roofs and some other elements. Sketch mode can always be identified in Revit by the presence on the ribbon of a green tick and a red cross. If ever you see those, you know that you are in sketch mode. Now it's important to note, when Revit is in sketch mode, there is only 2 ways to get out of it. You can either complete the sketch, so whatever Revit's expecting you to do now, you finish that operation. Normally involves you sketching out some boundary lines or a path. So you complete that, hit the green tick. Revit will then continue with the command. So in this case, it will then make the floor element based on your sketch. Or if you've changed your mind and you don't want to proceed with creating that element, you hit the red cross to cancel out of the current tool. So in this case, the floor creation process. When you're in sketch mode, hitting that modify button, which we've done time and again to cancel out of commands, won't work. So you've only got one of 2 options: either proceed with the sketch, hit the green tick to complete the operation, or reverse out of it by hitting the red cross. Okay, so let's just take a look at what's happened here. We've selected the floor tool, we've gone into sketch mode. Revit is now asking us to define or draw the boundary where we want our floor plate to be. To do so, we have a draw palette here, so we've got a number of different tools to allow us to draw that boundary, and it's totally up to you which tool you use. So we could use, for example, a single line segment. And just like most CAD systems, you just click round where you want those lines to be. Now I'm just going to delete those for now. Delete that one. Just to show you the different options you've got to define that boundary. So it's a boundary line I want, because it's the boundary of the floor we're defining. So as we've just seen, I can draw single line segments. I've got a range of standard polygons there. The floor boundary can be any shape you like. It can consist of curves, arcs, these polygons, splines. We've got a pick lines tool there. That's the first time we've really come across that. I'll explain that in detail later on in the course, but that allows you to pick lines that already exist in your project. So quite typically you might have a DWG file that you've brought in and that you're seeing underneath, and you can use that pick lines tool and it will detect the lines in the DWG file. So you can almost sort of trace over a DWG footprint where you want your floor to be. But in this case, that last icon is really useful. Pick walls. So this is going to now detect where we have walls in the model, and if you watch my cursor, as we hover over the walls, it's now detecting them. Now a really neat trick is if you have drawn your walls in a chain, all you need to do, instead of clicking on each of these, because I could just click now and it would select that wall, then click that one and so forth. If I hover over one of the walls and I use the tab key on my keyboard, you notice how Revit has automatically detected the chain of walls. It's actually come up there as the little tooltip. Now I can click my left mouse button and you can actually see a pink line that Revit's created. That is the boundary of the floor element. Notice on the options bar this tick box here, extend into wall to the core. With that ticked on, Revit has detected the walls and it's detected the core boundary. Now we'll cover that in a little more detail later on in the course, but as we saw very briefly in the walls unit, walls are made up of 3 zones, a core zone and then a finishes zone either side. So basically, with that ticked on, Revit can automatically determine where that core boundary is in the makeup of whatever wall type you're using, and it can make an adjustment to set that boundary of your floor inside on that core boundary. Now, just before we go ahead and make the floor, just a couple more things about sketch mode. Normally when you're in sketch mode and you've drawn a sketch, Revit is very prescriptive about what that sketch must consist of. In this case, it needs to be a complete closed loop. If, for example, these lines didn't quite meet at the corner, even by a couple of millimeters, it wouldn't be acceptable for Revit, and as we try to proceed past here, we get an error message and we'd have to correct the sketch. Likewise, even a rogue piece of line like that now would not be deemed acceptable because it just confuses Revit. It doesn't know how to make up this floor with that line included. So to begin with, a lot of people when they start out with Revit find the sketch mode can be quite frustrating because sometimes it's not clear or not self-evident why Revit is complaining about the sketch that you've drawn. Likewise, even if we added another pink line on top of one of these, that wouldn't be acceptable. It's just got to be a closed loop with no straggly bits or no gaps. Okay. And finally, the only other thing I'll mention before we proceed are these 2 extra lines here. We just said we can't have additional straggly lines. These lines here are actually the span direction of the floor. So if you think of those as a symbol that's been put in by Revit automatically, we can change that span direction very easily by just hitting span direction there and then clicking on one of the lines where we want that span direction indicator to be placed. For the purposes of this course, don't concern yourself too much with where that span direction indicator lies. If you get into Revit structure, it becomes a lot more important, working out structural calculations based on steel profile sheets that lie in the same span as your floor element. Okay, so we've got a complete sketch. The next thing to do is to choose a floor type. If we look over at the properties palette, At the top we've got the type selector, and we can see the currently selected floor type. So we click that. We'll have a number of different predefined floor types. That will vary depending on how your template is set up. So you might see different entries in here, don't worry about that. So it just depends on the localization of your template file from Autodesk. Let's work with this one that's already selected. If I select Edit Type, we can see the type properties that make up that particular floor type. You'll notice that this is almost an identical panel to the one we saw in the walls unit. And again at the top there we had structure with an edit button, exactly the same. So if we select that and just take a quick look, very similar setup to the one we saw in the walls unit, i.e. this sort of spreadsheet with a number of rows that correspond with layers in the floor structure. So this is where you drill down to change the makeup of your floor. So you've got a function, you've got a material. So every element in Revit has to be made from a material. You've got a choice there. Each layer has a thickness, whether it's a structural material, and option for one of those layers to be variable. Now we will talk about that in detail in the next unit on sloped floors, so I won't go into that here. Just wanted to show you this dialog box. So I'll OK that. Remember, if you want to make up your own floor type, exactly the same process as we looked at in the walls unit, i.e. choose a floor type first that's similar to what you're after, hit Edit Type, then hit that duplicate button, give it a new name, go into that structure, change, add, delete layers as required, form your own floor type, and that will become then available to you in the type selector. So for now we're going to stick with this floor type. Remember the instance parameters at the top level of the properties palette. So level, what level is this floor going to be created at? It's going to be level 0. Revit sets that automatically because it detects what level is associated with the view in which you're working. So remember when we looked at views and how they related to levels, and we said each view has an associated level. So when we're working on the ground floor plan, i.e. this level 0 plan, level 0 is associated with that view. So Revit can fill that in automatically for us. So the floor is going to be created at this level in which we're working. So got our sketch, got our floor type, the level's correct. All we need to do now is hit the green tick to go ahead and create the floor. And there it is, the floor's been created. It's still selected, just to show you guys that we have indeed got a floor element. So I'm just going to deselect the floor first, and if I switch to a 3D view, there we are, we can see the floor that we've just created. Now I'm just going to switch back to level 0, and before we do anything else, I'm just going to very quickly create a section through our building. So don't worry too much about how I'm doing this. I've got a dedicated unit on creating and modifying sections, so we'll look at that later on. But for now I just wanted to create a quick section. Open that up. Now if I increase the detail level to fine, just want to show you guys the completed floor that we've created. It is in fact made up of the various layers. Remember, I select the floor, edit type, structure, those layers listed there are the layers that you're seeing in the floor element itself. The important thing to note here is that floors are built downwards with reference to the level that they're associated with. So if you remember, with that selected, this floor is associated with level 0, so level 0 lies along the top surface of the floor. So no matter how thick your floor element is, it will always work its way down from that level. You'll see the opposite is true when we get to roofs. Roofs are actually built up from their associated level, but we'll look at that in a separate unit. So I mentioned briefly before about editing the structure or the build-up of the floor. Let's look at that in a little more detail now. Let's create a new floor type and edit its structure, just to show you guys how that's done. So there's the current floor type. We can see that in the type selector. We want to create a new system family type for this floor. So edit type. There's the current type. Let's duplicate that. Revit gives it a new name, takes the old name, adds a number 2 at the end. We'll just stick with that for now. So if I hit OK, I can now hit edit structure. There is the build up. If I just widen that a little bit, makes it easier to see the entries in the table. So there are the various layers and their thicknesses in our floor. So let's go ahead and increase the thickness of this layer to 400 mil. Hit OK. Hit OK again. And there you can see instantly the thickness of the floor changed, and notice how it got thicker downwards away from that level. So the top surface of the floor will always be consistent with the level it's associated against, and any variance in thickness of the floor type will go up or down from that level. So that's how you create your own new floor types. So what if you need to change the shape of the floor that you've just created? If I switch back to my level 0 floor plan, we select the floor. So let's say we want the floor, for whatever reason, not to extend to this far wall. We want it to stop short, maybe cut it out, put an arc in there. So basically change the boundary line. All we need to do is select the floors we've done here, and in doing so you will see an option on the ribbon to edit boundary. So go ahead and click on that, and all that does is put you back into that sketch mode step. See the green tick and the red cross again, that palette of tools to enable you to create the boundary lines, and there are the 4 pink boundary lines that we previously put in. So what I'm going to do now is delete that one. I'm going to add in a new boundary here. Just going to mix it up a little bit to show you guys you really can have whatever shape floor you want. It's worth mentioning here while I do this that although we use the pick walls tool to automatically find the walls, that was just an aid to really get those boundary lines in quickly along the perimeter of our building. But as far as Revit's concerned, it's not worried in the slightest where your boundary lines go. It doesn't do any automatic checking to see if your floor is supported or anything like that. It's totally up to you to define where you want the boundary of that floor to be. And this is a good example here because there's obviously no support to much of this floor now. Revit's not concerned at all, but what it is concerned with is this a valid sketch in which to make this new floor element? And at the moment, no, it's not. Remember, we said it's got to be a closed loop, so this extension past here is not acceptable, nor is this one down here. I'll just tidy that up with the trim to corner tools. Now I'm going to go through all these modification tools in detail shortly in the course, so don't worry exactly at the moment how these work, but I'm just going to use that, tidy these up. So now we have got a complete closed loop for our new floor shape, and all I need to do is, as we did before, click on the green tick to complete the operation and remake the floor with its new boundary. There we go. Deselect it, switch to 3D, and if we just orbit that model a little to show you in there and from underneath, there's our new floor shape. So we've just seen how we can easily edit the boundary of our floor element to change its shape. But what if we want to add an opening or an aperture inside the floor element itself? That's quite easy to do, and I'm going to show you how that works now. But to do so, I'm going to create a new floor at first floor level, because it just gives me the opportunity to show you guys quickly again that process. So I'm going to now switch to level 1 floor plan. So our first floor, you can see the outline of the floor below. Notice how Revit presents that in a greyed out line style because it's slightly in the distance, it's below us. There's our section line. So floors, remember architecture, floor, floor architectural. Remember that sketch mode, green tick, red cross. I'm going to work with the same floor type as before. So I'm just going to use that pick walls tool again. So pick walls, turn off that extend into wall core this time. Hover over a wall, use the tab key to select a chain of walls and a click to place the boundary lines. Notice this time, if I just zoom in a little, because we didn't ask Revit to extend into the wall to the core boundary, it's placed those boundary lines exactly on the surface of the wall, so on the surface of the plaster layer. Zoom back out. Remember that span direction, you can change that easily. Just toggle that from boundary line to span direction, whichever way your floor's spanning. Probably be the shorter distance in this case, so I'll just put that back. Let's switch back to boundary line for now. Okay, now we want to form an aperture in the floor, so this could be an atrium, it could be a stairwell, a lift shaft. All we need to do is simply form another closed loop within our main closed loop. So there's our boundary of the floor. Let's draw our aperture. Remember our alignment lines we looked at earlier in the course, so it's helping me to line up that there. Switch to an arc. So I'm happy with this atrium here. We could have, for example, a staircase or a lift coming up in the corner. So it's a closed loop inside our main closed loop. Now it's worth noting at this point, in fact I'll do it just for demonstration purposes, you can have as many closed loops inside the main one as you want, as long as they don't overlap. So they're distinct closed loops, no overlapping lines, and Revit will be happy at this point. We can see how happy it is by hitting the green tick. If everything's correct, it will go ahead and make the new floor. So there it is. Switch to 3D and just orbit the model, and we can see our upper floor with our openings in place. Now I would say at this point, in practice, forming your apertures like this is probably not the most efficient way to do them. I'm going to show you later on in the course the shaft opening tool, which is a much more efficient way of adding openings up through your floors. The reason I say that, I'll mention it now why that's a better method. If this was a live project and let's say for example this was a lift shaft here, and let's say for example this was a 10-story building, so we've got 10 of these floor plates we've created. If the lift is in the wrong position and I need to move it over a meter to the left, I've got to go in each of these floor plates, edit boundary, move this over, remake the floor. I could do that then for each of the other 9 floor plates, or I could delete those, adjust the first one and copy those up. That would be one way of doing it. But when I show you the shaft opening tool, you'll see that we can just create all our floor plates with no openings and then quite simply create a shaft opening through all of them in one go, and we can make adjustments to that very easily. So just wanted to show you how you can make openings in your floor elements by using that closed loop with inside your boundary. However, in practice I think there's a much better way of doing that, which I will go through later on in the course.
And that completes this unit. To get the most out of this training material, please take the complete course online at bimscape.com. Here you will find a complete learning management system that allows you to work through the course at your own pace. Comprehensive written tutorials provide additional information to that found in the training videos. Mark each unit as complete as you finish it and move on to the next. At any point you can return to any of the units you have previously completed to go over the material again. If you'd like to take this course online, please visit www.bimscape.com/Revit for details.